In 1928, the astrophysicist Arthur Eddington, the man who confirmed Einstein's general relativity by measuring starlight bending around the sun, stood before an audience in Scotland and said something no one expected. He said the stuff of the world is mind stuff, not metaphor, not poetry. The physicist who understood the equations as well as anyone alive looked at what those equations could and couldn't tell him, and concluded that the missing piece might be something like consciousness. That quiet claim has been gaining momentum ever since. Tonight, we're tracing an idea that starts in ancient Greece, wins through quantum physics, and arrives at a question that's closer than you think. What if awareness isn't something brains invented, but something everything already has? There's a moment from June 2023 that's worth sitting with for a minute. A neuroscientist named Christoph Koch walked onto a stage in New York. It was a conference on consciousness, the kind of gathering where people spend entire afternoons arguing about whether a thermostat might have feelings, and he did something unusual. He conceded a bet, not a casual one. This was a bet he'd made 25 years earlier, back in 1998, with the philosopher David Chalmers. The wager was a case of fine wine. Koch had bet that within a quarter century, science would find it, the thing, the neural signature, the clear biological fingerprint that would finally tell us exactly how a lump of tissue becomes aware of itself. How neurons firing in patterns somehow give rise to the experience of tasting coffee, or watching snow fall, or feeling that quiet ache you get when you hear a song you haven't heard in years. 25 years passed, and science didn't find it. So there was Koch on stage handing Chalmers a bottle of Portuguese Madeira, and the audience laughed, because what else do you do when the deepest question in all of science just stays unanswered? It wasn't a failure of effort. Thousands of researchers had spent decades mapping the brain in extraordinary detail. We can watch neurons light up in real time now. We can build machines that predict what word you're about to think before you think it. And still, nobody can explain how any of that becomes experience. How the math and the chemistry cross over into something it feels like something to be. That gap, the one between the physical activity in your brain and the private, interior fact of your awareness, it has a name. Philosophers call it the hard problem of consciousness. And the reason Koch lost his bet is that after 25 years of some of the most sophisticated neuroscience ever conducted, the hard problem is just as hard as it was when he shook hands on that wager. Which is strange. We solved the structure of DNA. We photographed a black hole. We landed a robot on a comet hurtling through space at 40,000 miles an hour. But consciousness, the one thing each of us knows most intimately, the fact that there is something it is like to be you right now, listening to this, that remains unexplained, not partially explained, not almost explained, fundamentally, stubbornly, completely unexplained. And maybe part of the reason is that the problem runs deeper than most people realize, because it isn't just that we don't know how the brain generates consciousness. It's that we might not even know what the brain is made of, not really, not in the way that matters. There was a philosopher named Bertrand Russell. You might have come across his name. He's one of those figures who seem to have an opinion on everything and was annoyingly right about most of it. In 1927, he published a book called The Analysis of Matter, and buried inside it was a line that sounds almost offhand but is quietly devastating. He wrote that physics is mathematical not because we know so much about the physical world, but because we know so little. It is only its mathematical properties that we can discover. Sit with that for a second. What Russell was pointing out is that physics, all of it, every equation, every model, every elegant theory about fields and forces and particles, only ever tells you what matter does, how it behaves, how it relates to other matter. It tells you that an electron has a certain charge and a certain mass, and that it will do predictable things under predictable conditions. But it never, not once, tells you what an electron actually is. What it's like on the inside, if inside even means anything at that scale. It's a bit like knowing everything about how a clock works, every gear, every spring, every oscillation, without ever knowing what metal is. You can predict what the clock will do next. You can build a better clock, but there's something about the basic stuff that your description just doesn't reach. And this isn't a minor philosophical quibble. This is a gap at the very foundation of how we understand reality. Physics gives us structure, it gives us relationships, it gives us extraordinarily precise descriptions of behavior. But it is silent, completely, structurally silent, on the question of what the stuff actually is that's doing all the behaving. Russell noticed this, and nearly a century later his observation became the foundation for a view called Russellian monism, the idea that maybe consciousness isn't some strange addition to the physical world, some ghost in the machine that we need to explain away. Maybe consciousness is what matter is on the inside. Maybe it's the intrinsic nature that physics, by design, can never see. He wasn't the only one thinking along these lines. Around the same time, 1928 to be precise, an astrophysicist named Arthur Eddington was giving a series of lectures in Scotland, the Gifford Lectures, which are about as prestigious as academic talks get. Now, Eddington was not some fringe thinker. This was the man who confirmed Einstein's general relativity. During a solar eclipse in 1919, he measured the bending of starlight around the sun and showed that space itself curves, just as Einstein had predicted. He was, by any measure, one of the most respected physicists alive. And in those lectures, Eddington said something remarkable. He agreed with Russell, physics can only ever describe what matter does, how it behaves and relates, but it is structurally incapable of telling us what matter actually is in itself. That's not a bug in physics, that's what physics is. It's a science of structure and relation, and there's nothing wrong with that, except that it means there's a whole dimension of reality, the intrinsic nature of things, that physics simply cannot access. And then Eddington went further. He suggested that the stuff of the world is mind stuff. Mind stuff coming from the man who proved general relativity worked, not from a mystic or a poet or someone trying to sell you crystals, from a physicist who understood the equations as well as anyone alive, and who looked at what those equations could and couldn't tell him, and concluded that the missing piece, the part physics leaves blank, might be something like consciousness. It's a strange thing to hear from a scientist, but maybe it shouldn't be. Because if physics only describes the external behavior of matter, and consciousness is the one example we have of something's internal nature, the one case where we know what it's like to be a physical system from the inside, then maybe those two puzzles aren't separate at all. Maybe the reason we can't explain consciousness in physical terms is that consciousness is the physical term we've been missing. The inside of what physics only ever sees from the outside. That's a big thought, and we don't need to rush it. For now, just notice the shape of the mystery. A neuroscientist loses a bet because the brain's deepest secret stayed secret. A philosopher points out that physics never actually tells us what matter is. A physicist agrees and wonders if the answer might have been hiding in plain sight all along, in the one thing we can never doubt, the simple fact of our own awareness. It's late, and these ideas have been waiting a long time to be heard, so let's take them slowly. A long time, indeed, because the idea that everything might carry some flicker of inner life, that's not something a philosopher dreamed up in a university office last Tuesday. It's one of the oldest thoughts humans have ever had. The word itself, panpsychism, only shows up around the 16th century. An Italian philosopher named Francesco Patrizzi coined it, stitching together the Greek words for all and soul. But the intuition he was nomming had already been circulating for more than 2,000 years before he gave it a label. He was putting a word to something people had been feeling in their bones since before writing existed. Go back to around 600 BCE to the coastal town of Miletus in what's now western Turkey. Thales lived there, a figure often called the first philosopher in the Western tradition, though he probably would have found that title a little strange. He was more of a curious traveler, someone who studied the flooding patterns of the Nile and figured out how to predict a solar eclipse. But the thing he said that echoed longest wasn't about rivers or stars, it was about rocks. Thales picked up a lodestone, what we'd call a natural magnet, and watched it pull a piece of iron toward itself. And he said something that Aristotle would later record and puzzle over for years. He said, "Everything is full of gods. Not some things, everything." His reasoning was almost childlike in its directness. Here's a stone, and it moves iron. It reaches out and draws something toward itself. If a stone can do that, if a stone can act on the world around it, then maybe it has something going on inside. Maybe the boundary between the living and the non-living isn't as clean as we assume. Maybe the whole world is saturated with something we don't have a good name for, something like soul. Now you can hear that and think it's naive, a pre-scientific mind projecting life onto dead matter. And sure, Thales didn't know about electromagnetism. He didn't have the periodic table, but notice what he was actually doing. He was looking at the world without the assumption that most of it is dead. He started from what he could observe, a stone that acts, and followed the thought honestly. And he landed somewhere surprisingly close to where Russell and Eddington landed 25 centuries later, just approaching it from the opposite direction. They subtracted outward from physics until only inner experience remained. Thales added inward from observation until everything had a kind of interiority, different roads, similar destination. And Thales wasn't alone, not even close. Halfway around the world, and possibly even earlier, the Jain tradition was building an entire cosmology on a similar premise, but far more carefully worked out. Jainism is one of the oldest living religions, with roots that stretch back well before the Common Era, and at the center of its worldview is a distinction that shapes everything else: jiva and ajiva, animate and inanimate, soul and non-soul. But here's the thing that might catch you off guard. In Jainism, the category of jiva, the things that possess a soul, that have inner experience, is enormous. It doesn't stop at humans, it doesn't stop at animals, it includes plants, it includes water, it includes fire, air, and even what the tradition calls earth bodies, minerals, stones, soil. The elements themselves are considered alive in a meaningful sense, each possessing at least one kind of sensory awareness: touch. So a flame in the Jain understanding isn't just a chemical reaction, it's a being. A simple one, yes, with only one sense where a human has five, but a being nonetheless. Something that experiences, however dimly, something that matters morally. This is why traditional Jain practice involves such extraordinary care about what you step on, what you breathe in, what you consume. If everything around you is quietly alive, then every action carries weight. It's arguably the most systematically panpsychist worldview ever practiced at scale. Not a thought experiment, not a fringe academic position. A living ethical framework followed by millions of people for thousands of years, built entirely on the premise that consciousness isn't rare, it's everywhere. Complexity just determines how much of it shows. And then there are the indigenous traditions, so many of them, spread across continents, often developed in total isolation from one another, and yet arriving at something remarkably similar. Take the Maori concept of Wakapapa. It's often translated as genealogy, but that doesn't really capture it. Wakapapa is a framework of kinship that connects humans not just to their ancestors, but to animals, to rivers, to mountains, to stars. Everything exists within a web of relationship, and that web isn't metaphorical. It's real in the deepest sense the tradition knows. A river isn't a resource, it's a relative. It has its own identity, its own presence, its own kind of inner life. And this isn't unique to the Maori. In the Andes, the concept of Ailu describes a similar interconnected community that includes the land itself, the soil, the water, the mountains, as active participants, not passive backdrop. In Japanese Shinto, kami are spirits that inhabit natural features, a particular waterfall, an ancient tree, a striking rock formation. The world is populated with presences. And across indigenous Australian traditions, the songlines, those vast, continent-spanning paths of story and meaning, describe a landscape that was sung into existence by ancestral beings, a landscape that still hums with that original creative awareness. These aren't identical philosophies. They come from vastly different cultures, different climates, different histories. They disagree on plenty, but they share something that's hard to ignore, an unwillingness to treat the world as mostly dead, an insistence that the rivers and the stones and the sky are not just scenery, that they participate, that they have, and this is the part that's hard to say in English without it sounding like a metaphor, but it isn't one, that they have lives. Western philosophy has a habit of treating these perspectives as charming but pre-scientific, as something humanity grew out of, but maybe that confidence was premature, because here we are in the 21st century with our particle accelerators and our brain scanners and our carefully controlled experiments, and we still can't explain why there's something it's like to be you. The hard problem of consciousness hasn't gotten any easier. If anything, it's gotten harder. So when Thales said everything is full of gods, or when a Jain monk walks slowly to avoid harming the earth bodies beneath his feet, or when a Mari elder speaks of a river the way you'd speak of a grandmother, maybe those aren't failures of sophistication. Maybe they're pointing at something we've been too hasty to dismiss. The intuition that mind runs deep in nature, that it isn't a late arrival but something woven into the fabric from the beginning, that thought has been with us for as long as we've been thinking at all. It keeps coming back in different languages, in different landscapes, wearing different clothes. And it keeps coming back because the mystery it's responding to has never gone away. So that mystery kept coming back, and at some point a few philosophers stopped trying to explain it away and started asking a different kind of question. Not, how does consciousness arise? But what if it doesn't arise at all? What if it was already here? To understand why that question gained traction, real, serious, academic traction, you need to understand the corner that philosophy of mind had painted itself into by the late 20th century. Because by then, there were really only two respectable positions you could hold about consciousness, and both of them had a fatal flaw. The first was physicalism, the standard view, the one most neuroscientists and a lot of philosophers would default to if you cornered them at a dinner party. It says everything is physical. Consciousness is what the brain does. It's neurons, it's chemistry, it's computation of some kind, and eventually we'll figure out the details. We just need better tools, more data, a few more decades of research. The problem, and this is the problem Cox's lost bet made painfully visible, is that physicalism can't explain why there's subjective experience at all. You can map every synapse, model every signal, build a complete wiring diagram of the human brain, and you still haven't answered the question. Why does any of that processing feel like something? Why isn't it just information moving through biological circuitry in the dark with nobody home? That's the hard problem. And physicalism doesn't have a story for it, not a bad story, no story. The second option was dualism. Mind and body are fundamentally different kinds of stuff. Consciousness is non-physical, it's something else entirely, something that exists in a different category from atoms and electrons and brain tissue. This has the advantage of taking consciousness seriously. It says, yes, experience is real and it's not reducible to physics. Fine. But dualism has its own fatal problem, and it's been the same fatal problem since Descartes first proposed the view 4 centuries ago. If the mind is non-physical, how does it interact with the physical brain? How does a thought, something supposedly made of non-physical mind stuff, cause your physical hand to reach for a glass of water? Where's the bridge? What's the mechanism? Dualism never found one. It just kind of gestured at the pineal gland and hoped nobody would press too hard. So there you are, two options. One says consciousness is physical but can't explain why physical processes feel like anything. The other says consciousness isn't physical but can't explain how it connects to the physical world. Dead end meet dead end. This is the impasse that a philosopher named Philip Goff describes with a clarity that makes you wonder why everyone doesn't see it. Goff frames panpsychism as a middle path, not a weird compromise, not a desperate third option, but a genuine resolution. His argument goes like this: physicalism fails because it can't generate experience from non-experiential ingredients. Dualism fails because it can't bridge the gap between two fundamentally different substances. But what if experience isn't something that needs to be generated, and the gap doesn't need to be bridged? What if experience is already baked into the fabric of matter, not as an addition, not as an emergent surprise, but as something that was there from the start? It's a move that changes the whole geometry of the problem. You're no longer trying to explain how consciousness appears out of nothing, or how two incompatible kinds of stuff manage to talk to each other. You're just saying the stuff of the universe already has an experiential quality to it, and complex consciousness, the kind you and I have, is what happens when you organize that stuff in sufficiently complex ways. The ingredient was always in the recipe, we just didn't list it. Now Goff didn't arrive at this view through calm, methodical reasoning. His story is messier than that, more human, and honestly a little funny. He was a philosophy student, a committed materialist, the kind of person who took physicalism seriously as a worldview, not just an academic position. And one evening, he tells this story himself, he was sitting in a bar, probably a couple of drinks in, and a thought hit him that he couldn't shake. If materialism is true, if consciousness really is just what brains do and there's nothing more to it, then it should be possible in principle for there to be a being physically identical to him in every way, same neurons, same chemistry, same behavior, but with no inner experience at all. A philosophical zombie, lights on, nobody home. And the thing was, he knew that wasn't him. He was sitting there in that bar and he was conscious. He could feel the glass in his hand, hear the ambient noise, sense the slight unease of a thought he didn't want to be having. That was undeniable, which meant either his own worldview was wrong, or he had to accept that consciousness was something over and above the physical, something extra. He became what he calls a closet dualist. He didn't tell anyone, he just quietly stopped believing the thing he'd been arguing for, and he didn't have anything to replace it with. The discomfort got bad enough that he left philosophy altogether. He moved to Poland and started teaching English, just walked away from the whole enterprise, spent his days conjugating verbs instead of wrestling with the nature of mind. And then, the way these things sometimes happen, he stumbled on an article, Thomas Nagel's Panpsychism. Nagel is one of those philosophers who tends to say in 10 pages what it takes other people a career to figure out, and this piece laid out the logic for panpsychism in a way that Goff hadn't encountered before. It was like finding a door in a wall he'd been banging his head against. He came back to philosophy. He came back specifically because panpsychism offered him a way to be honest about consciousness without abandoning the physical world. But Goff wasn't the first to notice this logical pressure. A few years before his barstool revelation, in 2006 to be specific, a philosopher named Galen Strawson had published a paper that detonated like a small bomb in analytic philosophy. The title was almost provocatively straightforward, Realistic Monism, Why Physicalism Entails Panpsychism. Strawson's argument was sharp and it was uncomfortable, especially for physicalists. He said, look, if you're a physicalist, you believe everything is physical, fine. And presumably you accept that consciousness is real, that your experience of seeing red or tasting salt or feeling anxious is a genuine feature of the world and not some kind of illusion. Also fine, but if those two things are both true, if everything is physical and consciousness is real, then consciousness must be a physical phenomenon. And if consciousness is a physical phenomenon, then the capacity for experience must be present in the physical stuff itself, all the way down to the fundamental level. In other words, being a consistent materialist, a really honest, follow the logic wherever it goes materialist, might actually require you to be a panpsychist. That landed hard. A lot of physicalists rejected it. Some said Strawson was playing word games. Others said he was sneaking in assumptions, but the paper kept being cited, kept being discussed, kept refusing to go away, because the logic, whether you liked the conclusion or not, was hard to dismiss. If you won't call consciousness an illusion and you won't step outside the physical, then you're stuck with the conclusion that experiential qualities are fundamental, that they go all the way down. It's one of those arguments that doesn't feel like a revelation when you first hear it. It feels more like someone pointing out something that was already true, but that everyone had been politely ignoring. The hard problem didn't go away because physicalists wanted it to. Dualism's bridge problem didn't get solved because people stopped thinking about it. And panpsychism, whatever else you think of it, at least has the honesty to sit with both of those failures and propose something different. Not something easy, not something obvious, but something that takes consciousness seriously without pretending the physical world isn't real. A middle path, maybe the only one that doesn't require you to give up something you know is true. So we've got the logic, we've got the ancient intuitions, we've got a handful of very smart people saying in different ways that consciousness might go all the way down, but so far it's still mostly a philosophical claim, elegant, maybe even compelling, but abstract. What would it actually look like as a theory of reality? What kind of world are we describing? One person tried to answer that, and his answer was so ambitious, so detailed, and so strange that most of philosophy spent the next century not quite knowing what to do with it. Alfred North Whitehead was a mathematician first. He co-authored Principia Mathematica with Bertrand Russell, 3 enormous volumes attempting to ground all of mathematics in pure logic. That project nearly broke both of them, but Whitehead didn't stop there. In 1929, he published a book called Process and Reality, and if the Principia was an attempt to map the foundations of math, this was an attempt to map the foundations of everything. The core idea was deceptively simple. Reality is not made of things, it's made of happenings. We tend to think of the world as a collection of objects, atoms, rocks, tables, brains that occasionally do stuff. Whitehead flipped that. He said the doing is primary. The world isn't made of static little billiard balls bouncing off each other. It's made of what he called actual occasions of experience, brief, self-determining events that flare into existence, incorporate what came before them, add something of their own, and then perish. Every moment is a tiny act of becoming. Not just at the human level, not just at the biological level, at every scale, down to the subatomic. Now that phrase, occasions of experience, it's doing a lot of work and it's easy to misread. When Whitehead said an electron has experience, he didn't mean it's sitting there thinking about its day. He was very careful about this distinction. Experience for him was not the same as consciousness. An electron experiences its surroundings the way a plant turns toward light. There's a response, a taking into account, a kind of registering of what's around it, but there's no awareness of that response. No inner narrator, no, oh, I seem to be orienting myself toward a photon, just the orienting, just the bare fact of responsiveness. Subtle distinction, and it matters. Because one of the things that makes panpsychism sound absurd to a lot of people is the mental image of a conscious rock, a self-aware coffee table, an electron with opinions. Whitehead wasn't saying that. He was saying something quieter and honestly harder to argue with, that the capacity for experience, not reflective, self-aware experience, but the most minimal possible version of registering and responding, is woven into the fabric of what happens. It's not something that arrives late when brains get complex enough. It's there at the beginning, faint, almost imperceptibly faint, but there. And he didn't leave it at a single undifferentiated claim. He organized it. He proposed a kind of hierarchy, 4 ascending grades of experiential complexity, each building on the one below. At the very bottom are what he called barren physical occasions. These are events with negligible inner life, not zero but close. The vibration of an atom in a crystal lattice, maybe. Something happens, but the happening barely registers even to itself. It's the floor of experience, as thin as experience can get without vanishing entirely. One step up, simple physical feelings. This is where something like an electron responding to an electromagnetic field lives. There's still no consciousness here, nothing you'd call awareness, but there's something more than the barren level. A slightly richer taking in of context, a slightly more nuanced response. The difference between a rock sitting there and a compass needle swinging. Then come living occasions. This is where things start to get interesting in a way we can almost recognize. At this level, genuine novelty enters the picture. Self-determination. The organism doesn't just respond to what is, it has some say in what comes next. A bacterium swimming toward a nutrient gradient, a cell deciding to divide. There's a degree of freedom that wasn't present in the simpler grades, something that looks from the outside a little like choice. And at the top, high-grade mentality, conscious synthesis. The kind of experience where all those lower levels are integrated into something unified, something that can reflect on itself, something that has a perspective. You, me. The fact that you're following these words right now and they mean something, that you can hold an idea in your mind and turn it over and compare it to something you thought yesterday, that's high-grade mentality. Not a different kind of stuff from what the electron has. The same basic capacity, amplified, layered, woven into something incomparably richer. The whole scheme has a certain elegance to it. Consciousness isn't a switch that flips on at some magic threshold of brain complexity. It's a spectrum, a gradient. The lowest levels of reality have almost nothing, but almost nothing is not nothing, and as you move up in complexity, from subatomic events to molecules to cells to organisms to brains, the experiential quality deepens, not by adding something alien, by intensifying what was always there. And here's the thing, Whitehead wrote all of this in 1929. It took 75 years for someone to figure out how you might actually measure it. In 2004, a neuroscientist named Giulio Tononi, Italian-born, working at the University of Wisconsin, proposed something that sounds almost too clean to be real. He said, what if consciousness has a number? What if you could, in principle, calculate how conscious a system is? The number is called phi, written with the Greek letter phi, and what it measures is surprisingly specific. Phi doesn't track how much information a system processes. A hard drive processes enormous amounts of information, but presumably isn't conscious of any of it. Instead, phi measures something called integrated information, how much information a system generates as a whole, above and beyond what its individual parts generate separately. Think of it this way, you can have 1,000,000 switches, each flipping independently. That's a lot of information, but it's not integrated. Each switch is doing its own thing, and you don't lose anything by looking at them one at a time. Now take a system where the parts are so deeply interconnected that you can't break it into pieces without losing something, where the whole genuinely is more than the sum of its parts. Where what happens in one corner affects what happens everywhere else, and the system's behavior can't be predicted from its components alone. That system has high phi. That system, according to Tononi, is conscious. The higher the phi, the richer the experience. And the theory doesn't draw a line. It doesn't say phi of 0.5 or above you're conscious, below that you're not. It's a sliding scale. A thermostat has a tiny amount of integrated information. Its temperature sensor and its heating element are connected in a way that's marginally more than the sum of their parts, so it has a tiny phi, not zero. A proton, in principle, has some vanishingly small phi. A worm has more, a bird has more still. A human brain, with its 100 billion neurons and its trillions of connections, generates phi values that dwarf anything else we know of. It's Whitehead's spectrum translated into mathematics, the faint experience at the bottom, the full human awareness at the top, and everything in between, all measured by a single quantity. Consciousness as a continuum, not a category. Tononi calls his framework Integrated Information Theory, IIT for short, and whatever you think of its conclusions, the ambition of it is breathtaking. It's a mathematical framework that makes testable predictions about which systems should be conscious and which shouldn't. It says your brain is conscious and your liver isn't, even though they're made of the same cells, because your brain integrates information in a way your liver doesn't. And it says quietly, almost as an afterthought, though it's not an afterthought at all, that consciousness extends in principle all the way down to every system that integrates even a sliver of information, to protons, to the dust between stars. Whitehead said the world is made of experience. Tononi said you can measure how much. Between the two of them, panpsychism stopped being just a philosophical position and started looking like something you could, eventually, test. Whether that's comforting or unsettling probably depends on how you feel about the dust. So now we have this number, phi, and it's supposed to tell us how conscious something is. Not whether it's smart, not whether it's useful, not whether it can hold a conversation. Just how deeply its parts talk to each other in ways that can't be broken down into separate, independent pieces. And the first thing phi does almost immediately is make the world feel strange. Take a photodiode, you've walked past thousands of them. They're in automatic doors, in elevator sensors, in those little night lights that turn on when the room gets dark. A photodiode does one thing, it detects whether light is hitting it or not, on or off. That's the entire job. Under integrated information theory, that photodiode has a phi value greater than 0. It's tiny, barely a whisper of a number, but it's not nothing. And according to the logic Tononi laid out, a phi value greater than 0 means there's something it's like to be that thing, some vanishingly small flicker of experience, not thought, not awareness in any way we'd recognize, but a trace of something. A difference between the light being there and not being there that isn't just mechanical, but felt, if felt is even the right word at that scale. Now here's where the strangeness really starts to bite. Your laptop, your phone, the server farm humming away in some warehouse in Virginia, these are machines that can do things a photodiode couldn't dream of. They can translate languages, generate images, beat grandmasters at chess. And yet under IIT, a standard digital computer might have a lower phi than a single bacterium. Not because it's less complex, but because of how its complexity is organized. A computer's transistors work in parallel, processing information in modular, largely independent channels. Each little piece does its job without needing to know much about what the other pieces are doing. That's actually what makes computers so good at what they do, the modularity, the clean separation of tasks. But from IIT's perspective, that modularity is exactly the problem. The parts aren't integrated. They don't form a unified whole in the way that matters for phi. A billion transistors humming along independently might add up to less integrated information than the chemical signaling inside a single-celled organism, where everything is tangled together, where you can't pull one piece out without changing all the others. It's a strange inversion. We tend to assume that consciousness tracks with capability, that the more a system can do, the more aware it must be. IIT says that's not how it works. What matters isn't what you can do, it's how deeply connected you are on the inside. And then there's the thought experiment that really pushed people's buttons. Theoretical computer scientist Scott Aronson, he's not a philosopher, he's someone who thinks very carefully about computation, looked at IIT and worked out what happens when you take a large, simple two-dimensional grid of logic gates and arrange them in a specific pattern. Nothing fancy, no deep learning, no sophisticated architecture, just gates connected to each other in the right way. Aronson showed that this grid could, in theory, achieve a phi value far exceeding that of the human brain. Let that sit for a second. A flat grid of basic logic gates, not processing anything, not solving problems, not responding to stimuli, not doing anything at all, every element switched off. The grid disconnected from the outside world entirely, and according to the mathematics of IIT applied faithfully, without any special pleading, it would be more conscious than you. Aronson brought this up not because he believed it, but because he thought it was absurd. It was supposed to be a reductio ad absurdum, a way of showing that the theory has deeply counterintuitive consequences, maybe fatally so. If your theory of consciousness says that a silent, inert grid of logic gates outranks a living, breathing human brain, then maybe your theory needs some work. Tononi's response was essentially, yes, that's what the math says, and I'm okay with that. The theory doesn't care about what something looks like from the outside. It doesn't care whether the system is active or doing useful work. It only cares about the intrinsic structure, the way the parts relate to each other, the information they generate together that they couldn't generate apart. If a grid of gates has the right internal architecture, then according to IIT, it is hi-fi. Full stop. You can see why this makes people uncomfortable. It's one thing to say a photodiode might have a tiny spark of experience. It's another thing to say a dead grid of circuits might outshine your entire inner life. But the theory doesn't stop at circuits and thought experiments. In 2021, biologist Anthony Truavas and his colleagues did something that would have seemed absurd a few decades ago. They applied integrated information theory to plants. Not metaphorically, not as a loose analogy. They looked at actual plant anatomy through the lens of IIT and asked, where, if anywhere, does integrated information show up? What they found, or at least what the theory predicted, was that root tips and shoot tips, the growing points of a plant called meristems, looked like candidates for minimal consciousness. These are the spots where a plant makes its most consequential decisions, which direction to grow, how to respond to gravity, where to send resources. And the information processing in these tiny zones isn't modular in the way a computer is. It's tangled, interdependent, integrated. Chemical signals feed back on each other. Hormonal gradients shift in response to touch, to light, to the chemical signatures of nearby roots. The key insight, and this is what makes IIT so radical as a framework, is that the theory is, as Truavas put it, blind to brains, nerves, and synapses. It doesn't start with the assumption that consciousness requires neurons. It doesn't even start with the assumption that consciousness requires biology. It starts with a mathematical structure and then looks around the world to see where that structure shows up. And if it shows up in the growing tip of a bean sprout, then the theory says the growing tip of a bean sprout has some measure of experience. Which leaves us in a genuinely weird place, a photodiode with its tiny flicker, a supercomputer that might be less conscious than pond scum. A silent grid of logic gates that theoretically outshines every mind that's ever existed, and a bean sprout reaching toward the light that might have something going on inside that we don't have a word for yet. You can reject all of this, of course, plenty of smart people do, but the thing about IIT is that it doesn't ask you to take it on faith. It gives you a number. You can argue about whether the number means what Tononi says it means, but you can't argue that the math is wrong. The math is the math. The question is just whether consciousness is really the kind of thing that math can catch. And whether consciousness is the kind of thing that math can catch might be the easy question, honestly, because panpsychism has a harder one that's been sitting there, mostly unanswered, for over 100 years. It goes like this: say you accept the whole picture, that experience reaches all the way down, that every particle carries some flicker of interiority. Fine, but then, how does that become this? How do billions of tiny sparks of experience turn into the single, seamless, unified thing you're experiencing right now? You're not hearing a billion separate micro-experiences. You're hearing one voice, feeling one mood, thinking one thought at a time, more or less. How did all those fragments become a whole? William James saw this coming. Back in 1890, in the Principles of Psychology, he took panpsychism seriously enough to try to break it, and he did a pretty good job. He called it the mind dust theory, this idea that little particles of consciousness could just add up, like grains of sand piling into a dune. You get enough of them together, and eventually you've got a mind. James said no. He said the notion was unintelligible, not just hard to explain, genuinely incoherent, because you can stack as many grains of sand as you want and all you'll ever have is a pile. You won't have a beach towel. You won't have the smell of sunscreen. Something has to happen between the grains for anything new to emerge, and just putting more of them next to each other doesn't do that. That objection landed hard enough that philosophers gave it a name. They call it the combination problem. And more than a century later, it's still considered panpsychism's most serious unresolved challenge, not a minor technical quibble. The thing that any serious version of panpsychism has to answer, or else the whole framework stays stuck at the level of a beautiful intuition that can't explain the most basic fact about your own mind, that it feels like one thing, not trillions. The reason this is so stubborn isn't just complexity. It's not like we need a bigger computer or a better equation. The problem is more fundamental than that. The philosopher Sam Coleman has pressed this point in a way that's hard to shake. His argument is that subject summing, the idea that you could take many tiny conscious subjects and combine them into one big conscious subject, isn't just difficult, it's incoherent, and his reasoning is almost painfully simple. Think about it this way: a conscious subject, by definition, has a viewpoint, a perspective. It experiences things from somewhere, and that perspective inherently excludes other perspectives. You can't simultaneously occupy two different seats in a theater. You can be in seat 14A, or you can be in seat 14B, but you can't be in both at once. Not because the seats are too far apart, even if they're right next to each other, even if they're touching, each seat gives you a different angle on the stage. And the whole point of having a viewpoint is that it's yours, it's bounded, it's limited. That limitation isn't a flaw, it's what makes it a viewpoint at all. So if every particle has its own tiny viewpoint, its own micro-experience, you've got billions of perspectives. And Coleman says you can't just add perspectives together the way you add numbers. Two perspectives don't make a bigger perspective, they make two perspectives. The viewpoint of particle A and the viewpoint of particle B remain separate, each sealed in its own little theater, watching its own little show. There's no obvious mechanism, no logical operation that would merge them into a single audience. This is uncomfortable if you're rooting for panpsychism, because it suggests the theory might be beautiful and still broken at the most basic level. But not everyone thinks it's fatal. Hedda Hasselmorch, a Norwegian philosopher, has proposed what many consider the most promising response to the combination problem, and her key move is to change the metaphor entirely. She says the mistake is thinking about combination as stacking, as accumulation, as putting things side by side and hoping they merge. Instead, she talks about fusion. The distinction matters. When you put two hydrogen atoms next to one oxygen atom, you don't get hydrogen sitting near oxygen, you get water. And water is genuinely different from any of its components. It's wet. Hydrogen isn't wet. Oxygen isn't wet. Wetness isn't hiding inside either atom, waiting to come out. It's a property that only exists when the atoms enter into a specific causal relationship, when they bond, when they interact in a particular way. The whole is not just greater than the sum of its parts, it's different from the sum of its parts. Morch argues that mental combination could work the same way. Micro-experiences don't just stack up, they fuse. They enter into causal relationships with each other, and through that fusion, something genuinely new emerges. Your unified conscious experience isn't a pile of tiny experiences. It's what happens when those tiny experiences interact in the right way. The way water is what happens when hydrogen and oxygen interact in the right way. It's a helpful analogy, and it does real philosophical work. It explains why you can't just add up viewpoints, because that's not what's happening. What's happening is transformation. The micro-experiences don't survive the combination as separate things. They become something else. The way two people having a conversation aren't just two monologues playing at the same time. Something new is happening in the space between them. Whether this fully solves the combination problem is, well, that's still being debated. Critics point out that we understand the chemistry of water pretty well. We can trace exactly how hydrogen and oxygen bond, describe the molecular geometry, predict the properties of the result. But we have no equivalent understanding of how micro-experiences would bond. We can say the word fusion. We can point at the water analogy, but we can't yet describe the mechanism. The chemistry of consciousness, if it exists, hasn't been written yet. Still, Morch's approach shifts the conversation in an important way. It moves the combination problem from "this is logically impossible" to "this is scientifically incomplete." And those are very different categories. Lots of things were scientifically incomplete before someone figured them out. The question is whether consciousness is the kind of thing that yields to that kind of figuring. James raised the objection in 1890. Coleman sharpened it. Morch offered a way through, And the fact that all three of those moves still feel alive, still feel like the conversation is genuinely open, says something about the problem itself. It's not the kind of puzzle that gets solved and filed away. It's the kind that keeps growing as you look at it. So panpsychism might be right about the basic picture, experience all the way down, and it might still be missing the most important piece, how all the way down becomes all the way together. The sparks might be real, but no one's quite explained the fire yet. So the sparks are there maybe, and nobody's explained the fire, but that hasn't stopped people from trying to build a better theory of how the sparks catch. Some of them came from places you wouldn't expect. Roger Penrose is a Nobel Prize-winning mathematician and physicist, the man who proved that black holes are an inevitable consequence of general relativity. Not someone you'd picture wandering into the consciousness debate, but in the early 1990s, Penrose did exactly that, and he brought an idea so specific and so strange that it split the scientific community right down the middle. He teamed up with Stuart Hameroff, an anesthesiologist at the University of Arizona. Hameroff's day job was putting people's consciousness to sleep and bringing it back. He'd spent years thinking about what exactly his drugs were switching off. And together, they developed something called orchestrated objective reduction, or ORCH-OR if you want to sound like you've been to the conferences. Here's the idea. Inside every neuron in your brain, there are tiny protein structures called microtubules. They're part of the cell's skeleton. They give the neuron its shape, help transport molecules, do the kind of housekeeping work that cell biology has understood for decades. Nothing exotic about them, at least not on the surface. But Penrose and Hameroff said the microtubules were doing something else, something the standard biology had missed entirely. They proposed that quantum processes, the kind of delicate probabilistic events that govern the behavior of particles at the smallest scales, were happening inside these protein tubes, and that each time a quantum state collapsed inside a microtubule, that collapse wasn't just a physical event, it was a tiny blip of proto-consciousness. A momentary flicker of something experienced. Not a thought, not even a feeling in any way we'd recognize, more like a single pixel of awareness, if awareness could be broken down that finely. And the brain's job, in their view, wasn't to create consciousness from raw matter. It was to orchestrate these quantum-level micro-experiences, to coordinate millions of tiny collapses happening across millions of microtubules, conducting them into the coherent, unified experience you're having right now. The brain as conductor, not composer. The music already existed at the quantum level. The brain just figured out how to play it together. It's a beautiful idea. It's also been relentlessly attacked. Most neuroscientists argue that the brain is far too warm and wet for quantum coherence to survive. Quantum effects are fragile. They tend to dissolve the instant a system gets noisy, and the inside of a neuron is about as noisy as environments get. Penrose and Hameroff have pushed back, pointing to evidence of quantum coherence in photosynthesis, in bird navigation, in enzyme reactions. But whether microtubules actually support the kind of quantum processing ORCH-OR requires is still open, genuinely open. What matters for our purposes, though, isn't whether ORCH-OR is correct. It's what it shares with panpsychism. Notice the architecture of the claim. Consciousness isn't generated by the brain. It's already there in some form at the quantum level. The brain doesn't produce experience from non-experience. It takes experience that already exists and weaves it into something larger. That should sound familiar. Now, there's someone else who arrived at a very similar conclusion, but from a completely different direction. And his story is one of the strangest in this whole conversation. Federico Faggin is an Italian-American engineer. In 1971, he designed the Intel 4004, the world's first commercial microprocessor, the chip that made personal computers possible. He went on to develop the 8080, helped invent the touchscreen. If you're listening to this on a phone or a laptop, you're using something that exists in part because Fagin built the foundation. So when a man like that tells you he became a panpsychist, you pay attention to how it happened. In 1990, Fagin had a spontaneous mystical experience. He's described it publicly, without embellishment. He said he suddenly felt himself become both the observer and the observed. The boundary between his awareness and the world dissolved, not in a vague, floaty way, in a way that felt more real than anything he'd experienced before. The kind of moment that either rewires your worldview or gets filed away as an anomaly and never spoken of again. Fagin didn't file it away. He spent the next 3 decades trying to understand it. What he built slowly, carefully, with the rigor of someone who'd spent his career designing systems from the transistor up, is called quantum information panpsychism, or QIP. The core claim is this: consciousness is not a byproduct of information processing. It's intrinsic to quantum information itself. Every quantum event, every interaction at the quantum level, carries with it a minimal spark of experience, not because something magical happens when particles interact, but because experience is what quantum information is from the inside. If that reminds you of Russell, physics tells us what matter does, but not what matter is, and maybe what it is experience. That's not a coincidence. Fagin arrived at Russellian monism through engineering and mysticism rather than philosophy. Different road, same destination, or close enough to see the same skyline from where he's standing. What makes Fagin's version distinctive is the emphasis on quantum information specifically. Consciousness, for him, is tied to the irreducible, non-copyable nature of quantum states. A classical bit of information can be duplicated perfectly. A quantum bit cannot. There's something about quantum information that resists being fully described from the outside, that always retains a private dimension. And Fagin thinks that private dimension is experience. Most physicists haven't engaged with the idea seriously. Fagin published outside the usual academic channels, and the claim sits far enough from the mainstream that most researchers don't know where to put it. But the fact remains that one of the people who understood information at the hardware level better than almost anyone alive looked at the problem of consciousness and concluded it was there all along, in the information itself. And then there's the voice that says all of this, panpsychism included, might be looking at the problem backwards. Bernardo Kastrup has a PhD in computer engineering and a background in semiconductor physics. He's also a philosopher. His position is called analytic idealism, and it starts by accepting something panpsychism accepts, that consciousness is fundamental, but then takes a sharp turn that changes everything. Panpsychism says every particle has its own little flicker of consciousness, and the big mystery is how those flickers combine into minds like yours. Kastrup says no, there aren't billions of separate little conscious particles trying to figure out how to merge. There's one consciousness, one universal, undivided and primary, and what we call individual minds, yours, mine, the cat's, aren't pieces that somehow assembled themselves into a whole. They're dissociations within the whole, fragments that split off. He uses an analogy that sounds clinical but carries real weight. Dissociative identity disorder, what used to be called multiple personality disorder, is a condition where a single mind fractures into distinct personalities. Each alter has its own memories, its own emotional responses, sometimes its own name. They coexist within one brain, yet each experiences itself as complete and separate. Kastrup says that's what we are, alters of a cosmic mind that have dissociated. The separation is the illusion, not the unity. We feel separate because that's what dissociation does. It creates boundaries that feel absolute from the inside, even when the underlying mind is still one thing. It's a radical inversion. Panpsychism's combination problem, how do the little sparks become a big fire, doesn't arise because there were never separate sparks to begin with. There's just the fire, and we're the shapes the fire casts on the walls. Whether you find that liberating or unsettling probably depends on how attached you are to the idea that your mind is yours in some ultimate sense. Kastrup would say it is yours, in the same way that a dream character's experiences are the dreamer's, real enough to matter, but not the whole story. Three very different people, a mathematician staring into microtubules, an engineer who built the hardware of the information age and decided consciousness was in the information all along, a philosopher who threw out the whole idea of separate minds and said there's only one, dreaming us into existence. They don't agree on the details, but they share something. They all started by taking consciousness seriously enough to put it at the foundation, not as something that emerges late, not as a byproduct of complexity, but as something that was there first. And they each tried to describe what the world looks like when you stop treating awareness as the last thing that needs explaining and start treating it as the first. So far, all of this has lived mostly in the realm of argument. Ideas tested against other ideas, frameworks weighed against intuitions, thought experiments held up to the light and turned slowly. And that's fine. Philosophy has to do that work, but at some point a thought has to touch the ground. It has to make contact with the world where rivers flood and forests burn and lawmakers draft legislation, because some of these ideas are already changing how people treat the planet. Philip Goff, the philosopher who had his crisis in a bar and came back from Poland with a new worldview, has made a move in recent years that reshapes the whole conversation. For a long time, Goff defended what's called micropsychism. That's the version of panpsychism we've mostly been discussing. Fundamental particles each carry their own tiny flicker of experience, their own infinitesimal interiority. And the big puzzle, the combination problem, was how those separate little sparks become the unified consciousness you're experiencing right now. But Goff started to feel the weight of that puzzle, and rather than keep trying to solve it from the bottom up, he flipped the whole picture. His new position is called cosmopsychism, and it's a significant departure. Instead of starting small and working up, particles have experience, somehow they combine into minds. Cosmopsychism starts at the largest possible scale and works down. The universe itself in this view is the one fundamental conscious subject, not a collection of conscious particles, not a system that generates consciousness through complexity. The cosmos is conscious, period. It's the primary experiencer. And everything else, you, me, the cat, the ocean, the distant galaxy nobody's named yet, were derivative, fragments, particular expressions of a single underlying awareness, the way a wave is a particular expression of the ocean it belongs to. Goff is explicit about why he made the shift. The combination problem, James's mind dust objection, Coleman's theater seats, all of it gets its teeth from a specific assumption, that you start with many separate conscious entities and need to explain how they merge into one. Cosmopsychism dissolves that by refusing the starting premise. There were never separate conscious entities that needed combining. There was always just one. The question isn't how the fragments came together. It's how the whole came to express itself as fragments. You might notice that sounds familiar. Kastrup's analytic idealism covers similar territory, one universal consciousness, individual minds as dissociations within it. Goff and Kastrup would disagree on the details, and they do publicly with the kind of polite intensity that only philosophers can sustain for decades. But the structural move is similar. Start with unity, derive plurality. And the hardest problem in panpsychism suddenly looks very different. Whether you find that more convincing than the bottom-up picture is a personal call, but the shift matters for a reason that goes beyond abstract philosophy, because once you start from the premise that the universe is a single experiencing subject, something happens to your ethics, and that something is not small. Freya Matthews noticed this. Matthews is an Australian environmental philosopher, not someone you'd encounter in a mainstream consciousness debate, which is maybe why her work is more important than its reputation suggests. She developed what she calls living cosmos panpsychism, and the name tells you most of what you need to know. The cosmos isn't just structured, it isn't just complex, it's alive, not metaphorically. Not in the loose, poetic sense where people say the earth is alive and mean something about ecosystems. She means it literally. The universe is a self-realizing subject, it's doing something, it's experiencing itself into existence. And the ethical consequence drops out immediately, almost without effort. If the universe is a self-experiencing whole, then harming any part of it isn't just damaging an ecosystem or depleting a resource. It's harming something that experiences. It's causing something pain or loss or diminishment, whatever the cosmic equivalent of those words turns out to be. Ecological destruction isn't just bad policy or poor stewardship. It's a kind of violence against a conscious being. That might sound like a stretch, and in academic philosophy, Matthews's view is still considered heterodox, too mystical for some, too metaphysically loaded for others. But here's the thing. The practical implications of her framework look almost identical to what some legal systems have already started doing independently for completely different reasons. In 2017, New Zealand's parliament passed a law that most people outside the country barely noticed. It was called the Te Awatupua Act, and it did something that had never been done before anywhere in the world. It granted legal personhood to a river. The Wanganui River, third longest in New Zealand, running 290 kilometers from the volcanic plateau to the Tasman Sea. The Maori Iwi, the tribal communities who have lived along its banks for centuries, had been fighting for legal recognition of their relationship with the river since 1870. That's not a typo. They spent nearly 150 years in courts and in parliament, across colonial governments and democratic ones, making the same argument over and over. The river is not a thing, it's not property. It's not a resource to be managed, it's a relative. The phrase at the heart of the law is ko tiawa ko'o. I am the river, and the river is me. It's a statement about identity, about kinship, about the collapse of the boundary between self and environment that Western philosophy has spent most of its history reinforcing. We touched on Mariwakapapa earlier, the web of kinship that connects people to rivers and mountains and stars. The Wanganui River Law is that principle made concrete, written into statute, enforceable. The Act defines the river as an indivisible and living whole comprising all its physical and metaphysical elements. Physical and metaphysical. That language was negotiated by lawyers and legislators, not by philosophers, but read it again. An indivisible and living whole with metaphysical elements. That's a legal framework describing something that sounds remarkably like what Matthews is talking about, what Goff is talking about, what this whole conversation has been circling around. The river has two guardians appointed to act on its behalf, one from the Crown, one from the Iwi. If someone pollutes the river, they haven't just broken an environmental regulation. They've harmed a legal person. The river can sue, or rather its guardians can sue on its behalf, the same way a guardian can sue on behalf of a child. For most of modern legal history, the line between persons and things was sharp. Persons have rights, things have owners, rivers were things, forests were things, mountains were things, and then in a quiet chamber in Wellington, that line moved. New Zealand wasn't alone for long. In 2017, the same year, India's Ganges and Yamuna rivers received similar recognition, though the ruling was later challenged. Colombia's Atrato River was granted legal personhood. Ecuador had already written the rights of nature into its constitution back in 2008. Bolivia did something similar. The movement is still small, still contested, still working out what it means in practice, but it exists, and it keeps growing. And here's the part that sits a little sideways in the mind and won't quite settle. None of these legal reforms were motivated by panpsychism. The Maori didn't need Philip Goff to tell them the river was alive. They knew, they've always known. Their understanding preceded Western philosophy by centuries and didn't need its permission. The lawyers who drafted the Te Awatupua Act were responding to indigenous rights claims, not to debates about integrated information or micro-experience. But the convergence is hard to ignore. Philosophers spend decades arguing about whether consciousness goes all the way down, and meanwhile, on the other side of the world, a legal system quietly decides that a river is a person, not because someone proved it as phi, not because someone measured its integrated information, but because the people who knew it best said, "This is a living whole, and it always has been." Theory and practice arriving at the same place by different roads. The philosophers working their way down from abstract principles, the communities working their way up from lived experience, and meeting, roughly in the same strange territory, a world where the line between what thinks and what doesn't might be a lot blurrier than anyone in a courtroom or a philosophy department used to assume. Whether the science will eventually catch up to the law, or the law is out ahead of what science can ever confirm, that's a question that hasn't been answered yet. And it's the question that's been hanging over this entire conversation, getting louder with each section, impossible to avoid much longer. So the science finally tried to settle this. Not with another thought experiment, not with another philosophical paper, but with something that looks a lot more like how physics or medicine resolves disputes, a structured, adversarial collaboration. In 2023, two of the biggest theories of consciousness agreed to go head-to-head. Integrated information theory, the one we've been following, the one with phi and its panpsychist implications, squared off against global neuronal workspace theory, which is a more conventional view. The workspace theory says consciousness happens when information gets broadcast widely across the brain, kind of like a spotlight sweeping across a stage. It doesn't need anything exotic. No consciousness in thermostats, no experience in atoms, just neurons doing their thing in a particular pattern. The collaboration was pre-registered, meaning both sides agreed on the experiments and what would count as evidence before they ran anything. That's a big deal. It's designed to prevent either camp from moving the goalposts afterward. And the results were announced at that same New York conference where Christoph Koch had to hand over a case of wine for losing his bet about consciousness being solved by 2023, a detail that tells you something about the mood in the room that day. The results were complicated, not a clean win for either side, but if you looked at the scorecard and there genuinely was something like a scorecard, IIT did better than expected. Two of its three specific predictions passed the agreed-upon statistical threshold. Global neuronal workspace theory, none of its predictions cleared the bar, 0 for 3. That's a strange outcome to sit with. The theory that says your coffee mug might have a tiny flicker of experience outperformed the theory that keeps consciousness safely inside the skull, at least on these particular tests. It didn't prove panpsychism. Nobody was popping champagne, but the panpsychism-adjacent theory was on points ahead. And that's when things got ugly. A few months later, in September 2023, an open letter appeared, signed by 124 researchers. The letter didn't just critique IIT or raise concerns about its methodology. It called integrated information theory pseudoscience. That word, pseudoscience, carries real weight in academia. It's the label reserved for astrology, for homeopathy, for things that dress up in the language of science without actually being testable. Putting it on a theory developed by one of the most cited neuroscientists alive was, to put it mildly, a provocation. The core argument was about falsifiability. The letter said IIT's central claims can't be empirically tested. That this measure of integrated information, can't actually be computed for anything as complex as a human brain, that the theory makes claims about consciousness in systems we can't access or verify, and therefore it isn't science at all, it's philosophy pretending to be neuroscience. Which is a reasonable concern, actually. Computing phi for even a moderately complex system is practically impossible with current methods. The math scales in a way that makes it intractable, so there is a genuine question about whether IIT can ever be fully tested. But the backlash to the letter was almost as intense as the letter itself. Anil Seth, who's no IIT cheerleader, he has his own theories, called the pseudoscience label inflammatory, and he had a point. There's a difference between saying this theory has untestable elements and saying this is pseudoscience. One invites further work, the other tries to shut the conversation down. Eric Hole, a physicist who's done significant work on information theory, made an even sharper observation. He pointed out that the same criticism, that the core claims can't be fully tested, applies to virtually every other theory of consciousness. Global neuronal workspace, it can't tell you definitively whether a given system is conscious or not. Higher order theories, same problem. The hard problem of consciousness isn't hard because one particular theory is bad. It's hard because consciousness resists the kinds of clean empirical tests we're used to in other sciences. So what the letter really exposed wasn't a flaw unique to IIT. It exposed how raw the entire field is, how close to the surface the frustration runs. Scientists who study consciousness for a living still can't agree on what counts as evidence, what counts as a theory, what counts as legitimate science when you're trying to explain the one thing in the universe that can't be observed from the outside. And underneath all of that, there's a discomfort that nobody in the letter quite said out loud. If IIT is right even partially, then consciousness isn't special to brains. It's woven into the structure of matter itself, and for a lot of working scientists, that conclusion feels wrong. It feels like giving up the thing that makes neuroscience important, the idea that the brain is where the magic happens. Panpsychism, even dressed up in mathematics, still sounds like mysticism to some ears. And when something sounds like mysticism, calling it pseudoscience is the fastest way to make it go away. It didn't go away, the debate is still active. The adversarial collaboration is continuing with new experiments. But the 2023 episode left a mark. It showed that consciousness science isn't just an intellectual puzzle, it's personal for the people doing it. And then there's the part of IIT that creates the strangest tension of all. Not with other theories of consciousness, but with artificial intelligence. We touched on this earlier, how IIT measures consciousness by integration, by how much a system's information is bound together beyond the sum of its parts. A photodiode has a tiny bit, a brain has an enormous amount, but a standard digital computer, the kind running every AI system you've ever interacted with, might have essentially none. That sounds counterintuitive. A large language model can write poetry, explain quantum mechanics, hold what feels like a genuine conversation. But if you look at the architecture underneath, it's built from independent logic gates, each one doing its own small calculation and passing the result along. The information isn't integrated in the way IIT requires. It flows through the system, yes, but each component can be understood in isolation. The whole isn't doing something fundamentally different from what the parts are doing separately. And for IIT, that's the only thing that matters, not intelligence, not behavior, not how convincing the output is, just integration. Koch and Tononi pushed this to its logical extreme. They argued that you could build a perfect digital simulation of a human brain, neuron for neuron, synapse for synapse, every connection replicated exactly, and it would behave identically to a conscious person. It would say it's conscious. It would react to pain. It would write love letters and grieve losses and argue passionately about its own inner life. And according to IIT, it would experience nothing at all. Lights on, nobody home. That's a genuinely unsettling idea. Not because it demotes AI, honestly that part is almost reassuring in a world that's increasingly anxious about machine consciousness. It's unsettling because of what it says about the relationship between doing and being. We tend to assume that if something acts conscious, it probably is. That behavior is evidence of experience. IIT says no. Behavior and experience can come completely apart. You can have all the right outputs with none of the inner life. Which means a thermostat with its tiny sliver of integrated information might have more experience than the most sophisticated AI ever built. Your laptop processing trillions of operations per second, generating text and images and music, and according to this framework, it's less conscious than a light switch. There's an irony here that's hard to miss. the theory that gives consciousness to everything, to protons, to plants, to the air in this room, takes it away from the one thing we're most worried about having it. The machines, the algorithms, the digital minds we keep building and then nervously wondering if we've created something that can suffer. Maybe that's comforting. Maybe it means the AI question is simpler than we feared. Or maybe it just means we're measuring the wrong thing. Maybe integration isn't the whole story, and whatever consciousness actually is, it's slippery enough to show up where we aren't looking for it and hide where we are. The honest answer is that nobody knows. The experiments continue, the arguments get sharper, the theories multiply, and the question of whether everything around you is quietly conscious, or whether consciousness is rarer and stranger than any current theory can capture, remains exactly as open tonight as it was when we started. We met William James earlier tonight, wrestling with mind dust, trying to figure out how tiny sparks of experience could ever combine into a single, unified consciousness. He never solved that puzzle, but James had another side to him, one that most philosophy textbooks leave out. In the 1880s, he started inhaling nitrous oxide. Not recreationally, or not entirely recreationally, he was chasing something. He wanted to know what consciousness looked like from a different angle, the way you might walk around a sculpture to see the side that faces the wall, and what he found unsettled him. Under the gas, he felt what he called the tremendously exciting sense of an intense metaphysical illumination. He scribbled notes to himself while the room tilted. When he sobered up, he tried to make sense of them. What he arrived at was this: our normal waking consciousness is just one special type of consciousness. All around it, separated by the thinnest possible barrier, he said the filmiest of screens, there exist entirely different forms of consciousness, not unconsciousness, not blankness, different kinds of awareness, different textures of experience, flowing alongside ours like parallel streams we never notice because we never look. That was 1882, over a century before modern psychedelic research began confirming, in its own careful way, that he might have been onto something real. In 2022, Sandeep Nayak and Roland Griffiths at Johns Hopkins published a study that would have made James sit up straight. They tracked people who'd had a single powerful psychedelic experience, one that changed their beliefs in some fundamental way, and measured how it shifted their sense of where consciousness exists in the world. The results were striking. Before the experience, about a third of participants were willing to say insects are conscious. Afterward, that number jumped to 57%. Fungi went from 21% to 56%. And even inanimate natural objects, rocks, rivers, the kind of things most Western-educated adults dismiss without a second thought, went from 8% to 26%. These weren't fleeting impressions. On average, the shifts persisted 8 years after the experience. 8 years. A single afternoon that rewired how people saw the world around them, and the change stuck. Now you can interpret that a few different ways. Maybe psychedelics just make people credulous. Maybe the experience is so overwhelming that it leaves behind a kind of residual openness, a looseness in the categories that used to feel rigid. That's possible. But there's another reading, and it's the one James would have recognized. Maybe the screens really are that filmy. Maybe ordinary waking consciousness is, among other things, a filtering mechanism, something that narrows our attention to the signals that help us survive and navigate while screening out the vast hum of experience happening all around us. And maybe when that filter relaxes, what floods in isn't hallucination. It's information we were always ignoring. You don't have to believe that to find it worth sitting with. The point isn't to declare that mushrooms have feelings. The point is that our sense of where consciousness stops, our intuitive line between things that experience and things that don't, turns out to be far less stable than we assumed. A single afternoon can move it, culture moves it, scientific evidence moves it. Even a quiet walk in the woods at the right hour can move it if you're paying attention. Which brings us to the part that keeps philosophers up at night, the ones who think about ethics anyway. In 2024, Joseph Gottlieb and Bob Fisher sat down to work through what panpsychism actually means for how we should treat things. Their conclusion was honest and a little anticlimactic, which is probably a sign it's close to the truth. Panpsychism, they argued, probably does significantly expand our moral circle. If everything has some form of experience, then everything has some claim on our consideration. That much follows logically. But and this is where it gets quiet, the expansion might not change much in practice. The reason comes down to a word that's doing double duty, sentient. When we say something is sentient, we usually mean it can suffer. It can feel pleasure and pain. That's the basis of moral status in most ethical traditions. A being that hurts deserves our care, but panpsychism doesn't say that electrons hurt, it says they experience, and there might be a vast difference between those two things. An electron's flicker of proto-experience, whatever that is, might be so minimal, so far from anything resembling suffering, that it simply doesn't register on the scale of moral concern. It exists, it experiences, but it doesn't need our protection any more than a single photon needs our sympathy. The experience is real, the moral weight might be close to zero. So panpsychism doesn't necessarily mean you need to apologize to your coffee table. It means the universe is richer than you thought, fuller, more saturated with something, but that something might not always be the kind of thing that demands ethical action. It might just demand a different kind of attention. And honestly, that might be enough. Not every philosophical insight has to end in a new set of rules. Some of them just change the way you look at the room you're sitting in. The lamp, the window, the air between you and the wall, not with anxiety, oh no, am I hurting the air, but with something closer to recognition. A quiet willingness to take seriously the possibility that experience didn't start with you, that it doesn't end with you. That it might be the most common thing in the universe, woven into the fabric of everything that exists, so ordinary that we overlook it the way we overlook gravity. James wrote his notes in the 1880s and spent the rest of his life trying to make sense of them. He never fully did. The screens stayed filmy, and he kept pressing against them, and the forms of consciousness on the other side never quite resolved into anything he could pin down with language. But he didn't stop looking. That mattered. Tonight we've followed a thread that starts in ancient Greece and winds through quantum physics and neuroscience and the legal rights of rivers, and it ends here not with an answer but with a question that feels different now than it did an hour ago. Not louder, just closer. The kind of question that doesn't need solving tonight. The kind you can carry with you into sleep, letting it settle somewhere below thought, where the filmy screens are thinnest and the world is just the world, quietly being whatever it is. That question, whether the world around you is quietly aware in ways we'll never access, isn't the kind of thing that needs an answer tonight. It's more like a lens you can pick up and hold for a while, just to see what ordinary things look like through it. The hum of a refrigerator, rain against glass, the weight of a blanket settling. Maybe there's nothing behind any of it, or maybe everything has always been gently lit from the inside and we just stopped noticing. Either way, it's a good thought to fall asleep with, and if it gave you something worth turning over, we'll be here next time with more.